Hi, Assalamualaikum warahmatullahi wabarakatuh, my dear students. I hope you have a wonderful 1 week off from study. So now that we have come to the second half of the semester, let's continue with organic chemistry, chapter 5 still, hydrocarbon, lesson 65, oxidation of alkene. Today we are going to explain the unsaturation test for alkenes, which is called Bayer's test, whereby alkene is going to be treated with cold dilute alkaline solution of potassium permanganate at room temperature. Then we're going to determine the position of double bond through ozonolysis and reactions of alkene with hot acidified potassium permanganate. Now, oxidation for alkene is divided into three reactions. The first one will use the reagent potassium permanganate, which is either basic or acidic. The alkene undergo number of reaction, which is here we're going to oxidize the double bond of restricted carbons. So the potassium permanganate can be in the form of basic, OH minus is the environment, cool and dilute, and another one would be acidic, it has acid as the environment, H plus, and it is hot and concentrated. Another reaction is ozone. So we call this reaction ozonolysis. O3 is the ozone, and then the catalyst is zinc, and the environment is H2OH plus. Here is the part of mind map which you have to fill in your course book on the bottom left. Please fill this in your book now. So the unsaturation tests which we have talked about is Bayer's test. The reaction is with basic dilute and cold potassium permanganate, whereby the color of the original reagent is purple, as you can see here, purple, banafsaji. And as it undergoes the oxidation, it will form 1,2-diols, or we also call this compound as glycols. And it is going to form another byproduct, which is called manganese dioxide. It gives brown precipitate. So it will give out solid at the bottom of the test tube. What is the observation for this reaction? We have to say two things. Number one, purple color of potassium permanganate will be decolorized. And number two, brown precipitate formed. You cannot say from purple turn to brown because it's a different product being formed there. So this reaction is also known as hydroxylation, and it's a chemical test to distinguish alkenes with other functional groups. Let's look at example 5.23, question number 1. As you can see here, the reactant given is alkene, which is having 2 carbons, which is called ethene. As it reacts with potassium permanganate in basic environment and cold dilute, it is going to form this compound which has 2 hydroxy group attached at both of the restricted carbons. So what is the name of this compound? Ethane 1,2-diol. Okay. Question number 2. What is the name for this compound? As you can see, there are 1, 2, 3, and 4 carbon. So the name is butene. Now, as it's going to react with potassium permanganate basic co-dilute, or some of your seniors called it BCD. They want to make it easy to remember. The 2-hydroxy group will be attached to the restricted carbon, and now the name is butane 1,2-diol. Question number 3. We have 2 double bonds here. So what is the product that is going to be produced from this reaction? Let's see. Yes, both of the double bonds will be occupied with as much as 4-hydroxy group now. And what is the name for this complex compound? Wow! Let's find the first carbon would be here. 1, 2, 3, 4, 5, 6. So the name of this compound would be 1-ethyl cyclohexane 1, 2, 4, 5 tetraol. Isn't it amazing? Okay, the second reaction, oxidation, is when alkenes is reacted with acidified, hot, concentrated potassium permanganate. Let's say we have 4 different R attached to our restricted carbon. When we react it with acidic potassium permanganate, we're going to produce 2 ketones. The first ketone is going to have R1 and R2 occupying the left part of alkene here. And the second ketone would have R3 and R4. It comes from the right part of this alkene. The most important thing that you have to remember for this reaction is that the carbon-carbon double bond, the restricted carbon, is going to undergo cleavage, whereby the alkene is going to be divided into 2 parts, the left part and the right part. So here we are going to have R2 and R1 attached to the first product, a ketone over here. And then the second product is the right part here. It only has 1 R and another one is H. So it's going to produce an aldehyde part over here, but since aldehyde is going to be oxidized further by potassium permanganate, it's going to produce carboxylic acid. Here is the third case. Since the oxidation of alkenes using potassium permanganate acidic is depending on the structure of the alkene, let's look at the double bond over here. It has R1 and R2 on the left side, so it's going to produce a ketone. The double bond is breaking, undergo cleavage, and is going to produce 2 compounds with a carbonyl group. So this carbonyl on the left would be a ketone, but on the right it has 2 H's, meaning that this methanol is going to be oxidized further by potassium permanganate and produce carbon dioxide and water. Let's look at example 5.24. The reactant is butene, and we can see here that the double bond is between carbon number 2 and carbon number 3, as we have drawn it using this style. So we know that the left hand side is going to give an aldehyde which is going to become oxidized further to become ethanoic acid. And we can see also on the right hand side is the same structure having one R and one H. So it's going to become an ethanol, and then it's going to be oxidized further also to become an ethanoic acid. So as you can see here, however the structure of alkene is given to you, you should be able to come out with the product, whether it is a ketone, it is a carboxylic acid, or carbon dioxide and water. Let's look at example number 2. As you can see here, the reactant is a propene, whereby if we draw it like this, we can look at the R clearly. One R on top here on the left side, so we're going to produce an aldehyde ethanol, whereby it's going to be further oxidized to become an ethanoic acid. As for the right side of the propene, you can see that there is no R, only 2H. So it is going to become a methanol. Methanol can be oxidized further to become carbon dioxide and water. It's not going to become methanoic acid, but it is going to become carbon dioxide and water. So the products for the oxidation of propene using potassium permanganate acidic with heat is ethanoic acid, carbon dioxide, and water. Let's look at question number 3. As you can see here, the reactant is a cyclohexane. The double bond is between the two of its 6 carbon. We have to draw it so that we can show the numbering of the carbon. So it's 1, 2, 3, 4, 5, 6. The carbon now is labeled, and we are going to split the double bond over here so that we can get two carbonyl group, and then it's going to become like this. So as you can see here, the carbon numbers are still attached so that we are not lost. And then what happened is it's going to be oxidized further, and the hydrogen here at the aldehyde end is going to become a carboxylic end. Now it's carboalkoxy group. Okay, another way that we can do is expand the product so that it's becoming a straight chain. This is the answer, whereby you can put carbon number 1 here, okay, next to carbon number 6. As you can see, carbon number 1 here is next to carbon number 6. So you can put number 5, 4, 3, and 2 next to them. Here you can see the name of this compound is hexane. Where is the carboalkoxy? It's at carbon number 1 and carbon number 6. So we label it hexane 1,6-dioic acid. Okay, let's look at question number 4. silap tu ya. Okay. So alkene here has a double bond between carbon number 2 and 3. It has 4R. 1, 2, 3, 4. So if we're going to have two carbonyl groups here, where it's going to be broken, the double bond is, so we are going to have one product, which is a ketone. What is this ketone called? 1, 2, 3, it's a propanone. And the other product would be 1, 2, 3, 4, it's a butanone. The third oxidation reaction of alkenes is ozonolysis, where we are going to use ozone molecule together with zinc as catalyst, and the condition would be H2O and H+. This alkene, as it reacts with the ozonolysis reagents, is going to form an unstable compound called molozonides, and molozonides will rearrange spontaneously to form ozonide. Ozonide is also an unstable compound, so it is going to break up into several parts. So it is going to form a ketone if it has 2R, and an aldehyde if it has 1R. It is going to stay as aldehyde and methanol if it has 2H, because the reagent is not an oxidation reagent. Ozone, zinc, H2O and H+ is not going to oxidize ethanol further, since they are not oxidation reagent. Let's do example 5.25, question number 1. The reactant here is, let's name this compound, 1, 2, 3, 4, 5. Baeyer. Okay, 1, 2, okay, 3, 4, 5. Okay, this is a pentene, but where is the double bond? It's at carbon number 2, so pent 2-ene, and it has one substituent at carbon number 3, so 3-methyl. The thing is, we are going to divide the double bond into half, so this is going to become one compound, and this part is going to become one compound. Here it is. This time around, the aldehyde here is going to stay as aldehyde. It's not going to be oxidized further. So the left compound here is an ethanol, whereas on the right side here, we're going to have 1 and 2R. So this is 1, 2, 3, 4. This is a butanone. Okay, for question number 2, the reactant here is butene. So we are going to draw it like this so that we can see how many R it has. On the left, we can estimate or predict that it's going to perform or produce methanol, whereas on the left, it's going to become propanol. Yes, here it is, the answer for the ozonolysis of butene. We get a methanol and propanol. For question number 3, this is a cyclic compound. We have 1R at the restricted carbon. The name of this compound is 1-ethylcyclohexene. So let's label the carbon. Which one is number 1? Here it is. This is carbon number 1 where ethyl is attached to it. So this part would become a ketone because there is 1R, the ethyl, and the other one is the cyclic. Whereas for carbon number 2 is going to have a part where it is an aldehyde. So let's draw it further. Here, as you can see, there is 1 and then 1 carbon is next to carbon number 6. 5, 4, 3, and carbon number 2. There would be a carbonyl compound both at the end of the compound, and we can also draw it using a straight line or straight chain compound where carbon number 1 is labeled here next to carbon number 6 here. And don't forget to draw the ethyl part, which is this one. And then 5, 4, and 3 would be the carbon in the middle here. And carbon number 2 is the one that is at the end, whereby is going to have a carbonyl group on it attached to 1 hydrogen. This is the aldehyde part, and this is the ketone part. The name for this compound is 1, 2, 3, 4, 5, 6, 7, 8. It's an octanol since aldehyde has a more priority than ketone. Ketone now is the substituent with the prefix oxo at carbon number 6, so 6-oxo-octanol. Well done. Now your job is to do practice 5.6, question number 1. All A, B, C, D, E, F, G, H, and I are the electrophilic addition, except for I, because I is the oxidation using dilute, basic and cold potassium permanganate. So you're going to have to draw the products. It can be an alkane, it can be a haloalkane, and also an alcohol. So look closely at what you're going to write. Question number 2 is on oxidation. So how are you going to form back an alkene that is produced from the oxidation? So the alkene given will be derived because you are having propanoic acid and butanoic acid as the product. What is the alkene that you're going to get from here? And then you have to deduce the structure of formula of alkene here. Comes from the ozonolysis of an alkene. So you get the alkene from this product. And finally, you're going to draw the structure of alkene when you are given these two products. So meaning that this alkene is a straight chain alkene, but for B, this is the cyclic alkene because you're going to put this carbonyl and this carbonyl together. All right. So we have learned all the reactions of oxidation on alkene, which is using Baeyer's test, the basic potassium permanganate, and then another reaction would be the acidic potassium permanganate, and the third one would be the ozonolysis. That's all for today. Bye.
Bye.
Assalamualaikum.
Assalamualaikum.
See you again.
Again.
Bye.
Bye.